Dear students, we are going to discuss about isomerism. Particularly, our focus would be on the isomerism of alkanes. So first we will try to understand what is the meaning of isomers. Isomers are those compounds which have the same molecular formula but different structures. And those difference in the structure may be because of several reasons, right? So if you have a molecule like A, B, C, where A is connected to B and B is connected to C, and in the other way they are connected like this, so their molecular formula would be A, B, C, but their structures or the connectivities are different. So this is one type of the isomerism. So isomers are two or more compounds having same molecular formula but different structures, right? Now if you look at these two molecules which I've shown here and you count the number of carbons in both of them, so there are 2 carbons in this one. How many hydrogens? 6 hydrogens. How many oxygens? 1 oxygen, right? So C2H6O. And here 2 carbons. Hydrogens 3 plus 2 5 plus 1 6. So both of them have the same formula, which is C2H6 and O, but the arrangement is different. If you look at this is carbon, oxygen, carbon, and then each carbon is connected to 3 hydrogens, CH3, CH3. So when you have this type of the linkage, COC, that represent that this is the special kind of organic compound which is called ether. And when you have this type of the thing, you call it alcohol, OH, right? So the name for this compound is dimethyl ether, right? And for this one is ethanol or ethyl alcohol. So both of them, they would have different physical as well as chemical properties, but the formula is same. Formula is same, but they would react differently with different compounds. They have different boiling points, right? The density is different, and the viscosity is different, so on. Now isomers are of different type. First category is constitutional isomers. Constitutional isomers, which the isomers which differ in their connectivity. The example we have done is the example of constitutional isomer, where the connectivity is different. How the different atoms are connected, that is different, right? So this is because of different connectivity. Then the second category is stereoisomers, where you have the connectivity is the same but different spatial arrangements, how they are arranged in space. For example, in case of alkenes, where you have a carbon-carbon double bond, you have a molecule like this, A and B groups on this carbon and A and B groups on this carbon. Now it can be arranged in a different way, A, B, and then B, A. In the first one, both A's are on same side of the double bond. In the second one, they are on the opposite side of the double bond. So such isomers, they are the stereoisomers or geometrical isomers to be particular. Their spatial arrangement is different. However, the connectivity is the same. Both the carbons are connected to A and B, connected to A and B. There's no difference in the connectivity, but the spatial arrangement is different. So stereoisomers are of 2 types, conformational isomers, configurational isomers. Conformational isomers, there's a separate video on conformational isomers. For example, in case of ethane, you have drawn the Newman projection formula when the ethane is in the eclipsed conformation, like all the hydrogens are behind each other. Hydrogens of one carbon are behind the hydrogens of other. The second one is when all are in the staggered position. So you have hydrogens, 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 hydrogen, hydrogen, hydrogen. So this is staggered one, right? Configurational, as we have already, I've told you about the geometric one, where you have double bond A, B and A, B. And in the second one, you flip this one, like B on that side, A on this side. That is a type of configurational isomer. And to be particular, we can call them geometrical isomers. The other type of configurational isomers are the isomers which contain chiral centers. Now, what's the meaning of chirality and all that? It's a separate chapter in itself, which deserves like 3, 4, or even 5 videos. And then we'll do some practice tests to find out what type of the isomers, stereoisomers are those and all that, right? So today our focus would be on the constitutional isomers, and that too the constitutional isomers of alkanes, right? So this is the example of alkane, which is hexane C6H14. The formula is written there, and in the bond line notation I can write it like this: 1, 2, 3, 4, 5 and 6, right? So this is normal hexane, N-hexane, right? The other way I can put this carbon chain is 5 in one row and the sixth one on the top of this. So this would be 5 and then the sixth one is this one. So the formula remains the same, but the arrangement of the carbon differs. So this is 2-methyl pentane, 2-methyl pentane, right? The other arrangement possible is that 5 in a row and then the methyl group here. And how would you name that? You start from left to right or right to left. The substituent is going to get the third number in this case. So this is 3-methyl pentane, right? What can be the other possibility? The other possibility is that you have 4 carbons in a row, right? And you put 1, 2, 3, 4 and you put 2 of them together here, okay? So you have 1, 2, 3, 4, 5 and 6. So 6 carbons and 14 hydrogens accordingly, right? But if I have to name it, and I name it like 1, 2, 3, 4, so it is the 4 carbon chain. But if I number it like this, 1, 2, 3, 4, 5, and we know that we have to go by the longest chain, right? So the correct numbering is this one. And what would be the name in that case? The name would be that a third carbon you have the methyl. So 3-methyl pentane. Fine. But we have already done that. So it means sometimes the compounds, they look that they are different, but they represent the same compound. Both of them, they are the same. It is just the way it is drawn on paper. So we will not count this one. So in order to avoid the confusions that you don't count the same isomer twice or thrice, it's good to look at the structure of that from the perspective of IUPAC nomenclature, right? Name it or look even at the longest chain, that will give you the idea, right? Now another isomer possible is if I have 4 carbons in a row, the 5th carbon and the 6th carbon I put here as substituents. So the name would be 1, 2, 3, 4. So at 2nd carbon I have 2 methyl groups. So 2,2-dimethyl butane, 2,2-dimethyl butane. Fine. The other possibility is I have 4 carbons, 1, 2, 3 and 4, and the 5th I put here and the 6th I put here, right? So it would be at 2nd and at 3rd we have methyl. So 2,3-dimethyl, and since it is a 4 carbon chain, so it would be butane, right? 2,3-dimethyl butane. So these are the different isomers of alkanes. What type of isomers? Constitutional isomers of hexane, right? Now sometimes they give you some compounds and ask you whether they're the structure and that structure are constitutional isomers or they represent the same compound. So I'm going to draw 2 structures here and will ask you whether they represent the same compound or not. So this is one of the structures and this is the other structure. Now how would I, by looking at them it looks they are quite different. So we will do the numbering, okay? If I do this numbering, 4 carbon. If I do this numbering, 5 carbons. But it give my substituents the number 3 and 4. And if I give this numbers 1, 2, 3, then my substituents are getting 2 and 3 numbers, right? So I would go by this way, okay? So 1, 2, 3, 4, 5. So the names would be, name of this would be 2,3-dimethyl pentane. 2,3-dimethyl pentane. Okay, what about the other one? Number 3, 4, 5. 5 carbons, so it is a pentane. At second and third, you have methyl. So 2,3-dimethyl pentane. So they represent the same compound. They are not isomers. They are the same compound, but it is written in a different way. Right? Now, we are going to discuss the relative stabilities of various isomeric alkanes. So these are the different isomers of hexane. Which out of them is more stable or which out of them is less stable? Now, one thing we know that stability is inversely related to energy. So the system which has more energy would be less stable. Okay, and if something has to be more stable, then it would have less energy, right? Now, another thing we know that when we burn alkanes in the presence of oxygen, what we get, all the alkanes when they burn in the presence of oxygen, like combustion happens, they release carbon dioxide and water along with heat. Okay, so this heat released, this negative sign here represent the heat released. Okay, delta H means change in enthalpy under standard conditions, but we are not going into the details of what enthalpy means. So you can take at this stage, you imagine it as the heat released, right? So the system which would have more energy would release more heat because it has so much of heat, so it can release on combustion. The same is true like if someone is having the less energy, so it would release less heat. So this is octane, 8 carbons. They will release 8 moles of carbon dioxide and 9 moles of water, right? So octane, and this one is also having 8 carbons. This is a branched isomer. 1, 2, 3, 4, 5, 6, 7, 8, right? Both of them are isomers, right? Both of them on burning releases 8 moles of carbon dioxide and 9 moles of water. The first one releases 5,470 kilojoules of heat per mole of the molecule, alkane molecule, and the other one is releasing this one. So which is higher number? This one is higher. It means this molecule, octane, has more energy than the branched isomer, right? It means octane is less stable than the branched isomer. Or in other words, the branched chain alkanes are more stable as compared to the linear chain alkanes, right? That is the conclusion which we have drawn. Fine. So branched alkanes or branched isomers are more stable. So we can actually do the experiment under controlled conditions using an equipment which is called calorimeter. Do the combustion reaction under controlled conditions and can accurately measure the amount of heat released, right? So I hope this clears what is the meaning of isomerism, what are the different types of isomerism, particularly the isomerism in case of alkanes, the constitutional isomers, how to identify whether two structures which are drawn, they are the same or they are constitutional isomers by naming them as per IUPAC, and then the relative stability of different isomeric alkanes. This is what we have discussed today. I hope this clears all these things, and if you find value in this lecture, please do subscribe to my channel. Thank you.